Hello everyone, how are you all? Welcome back to the channel again. I hope all are you good and learn something new with day by day. So today we discuss about a dead section, right? A dead phone repairing. Basically a dead phone repair, or you can say dead section itself a big section, right? A long section. So we could not cover in a one video, a single video. It's impossible to cover in a single video because a dead phone, behind a dead phone, if a phone come to you not turning on, right, there are multiple reasons like a protocol lines, right, a protocol communication lines, a short circuit, a software, a PMU does not work, right, your CPU does not work or requirements, your storage IC, your RAM IC. There are multiple reasons, right, for finding the fault in a dead phone, right. Now mostly technicians talk while the repair in a dead phone, even in a network, even a small fault like a light section. Why? Because the lack of knowledge about the schematics, right, how to work according to the schematics, how to read schematics, also about the circuit, how the circuit works, right, the clarity about the circuit. Also, in our field, this is a technology driven field, right, the update of each and everything, right, about the circuits are month by month, right. You will see a new circuits, right, before you will see a single PMU right now in a 5 PMU, a 6 PMU working in a single form, right. So it's little bit complicated, right, to understand the circuit without teacher, right. So if you face a problem, right, while repairing any fault, right, while troubleshoot, if you want to learn how to read schematics, work according to the schematics, right, if you know the systematic way, right, because if you find the fault, right, in an easy way, there is a systematic way, as you seen in our videos, even in a teaching, also in a study cases, we work according to the systematic way. There is a process we follow, there are some steps, so you can find easily the faulty components, right, the faulty lines. So if you learn this system about the schematics, about the circuits, and upgrade yourself, right, so you can contact us, right. I will guide you properly. I will teach you in a deep level schematics about the circuit knowledge, right. So in this number you can WhatsApp me any question, any query. I'll guide you properly. Now back to the topic about the dead phone, right. Now today, as I already told you, this is a big topic, right. So we covered a CPU related requirements. There are multiple requirements of the CPU, like a frequencies came to CPU. If the frequency did not enter the CPU, your phone does not turn on, right. TXRX lines called communication lines. This is also responsible. The external bus interface lines. There are also many communication lines. CPU needs also a buck section, a voltage requirement of the CPU. It's like a food for your body, right? First, after eat the food, your body digests the food. After it's converted into power, so you can work, right? Similar, the every chip, right, need a power for working, a voltage rail, right? So as a CPU needs a buck requirements, a buck voltages. There are also some voltages, right? So we discuss about the buck section in this video in a detail, in a depth, proper with the schematics, right? Maybe you already knew about the buck sections, but if you watch this video completely, you will learn something new, right? We go to the video and I'll teach you about the buck section, right? How the buck section work. Now, if you struggle with the network section, if you struggle with the dead phone, if you struggle with the display related faults, struggle with the audio related fault, now we cover each and everything in our classes. So if you want to join, right, contact us on a WhatsApp, right? Message me and I'll guide you properly. Let's go to the main circuit and understand the buck section in a deep level, right? Now, in front of you, there is a motherboard picture, right? Today we talk about these inductors, right? These buck inductors, these big components, right? Look at this. This is called buck inductor or coil, coil or inductors, right? First of all, for those who are beginner, let me tell you how to identify a PMU. If a phone come to you which had no schematics or no hardware solution, how to identify the PMU, right? Let's say a phone come to you with a single power, dual power, triple power. A simple rule, identify the PMU. Now, like this is a PMU, right? There are multiple chips on the motherboard, but near the PMU, you will see multiple buck inductors. Not one or two, it's a multiple. Let's say minimum 5 to 9 plus, right? Let's say a phone had a 3 plus PMU. So in this phone, you get 20 plus buck inductor near the PMU, right? A coil, basically. Number one. Now you can easily find without schematic, without hardware solution, which IC or which chip is PMU, right? Now, second, you will see this buck inductor. There are two types. First call a buck near the PMU, right? Second, boost, a similar coil. Look like similar, but the working difference. Now the buck used for high ampere, generate high ampere. With the switching, it generate high ampere. But the boost coil used for generate the high voltage, right? Like your buck, let's say, inductors or coils near the PMU. Used for high ampere. Mostly buck lines connected to the CPU. Connected to the CPU for give it power to the CPU. Because your CPU is like a human brain, right? Human brain control all your body parts. CPU control all your sleeves chips, like your camera chip, right? Your touch chip, right? Your graphics, right? Each and every chip controlled by the CPU. So CPU is your brain. Now, brain needs more power, right? That's why CPU needs high current, right? But it's working on a low voltage. So these bucks are low resistance line, right? But in these lines, you will get high ampere. I will show you. There is another feature in a wall new. I will show you also. Now the boost. You will see the boost coil used in a near the display IC, a graphic IC, or your screen. Now your screen need minimum 15 volt to 40 volt for brightness, to bright the screen, to light properly, right? Now it's the both inductors, the buck and the boost look like similar, but there is a difference. So by chance, any coil damage, right, buck or boost, you did not replace with the other, right? Only replace with the according to the value, right? Now clear. So I hope you will understood this a normal basic work, right? Now this basic information for those who are new, right? Now let's go to the schematics, right? And let's understand in a more deeper how these box section work, right? So we go to the schematic first, open the layout and layout. Now the PMU, these all are bucks, these L. Now the L means the L denote in electronic is coil or inductor. Like R for resistance, right? Sorry for the spelling. Resistance, like, right? C for capacitor, right? Q for transistor and MOSFET. So L for coil. So these are buck lines. So copy any one, right? Any buck, because PMU had many multiple blocks, right? So directly goes to the buck section. Shortcut, just copy this and paste in schematics. Now, directly we go to the buck section. Just zoom it. Now look at this. These all are bucks. In this IC, we get a 9 bucks, right? Now, how these bucks work? Why these buck lines? For which section in a CPU? I will give you all information, right? Now, whenever a phone come to you in a dead condition, right? Your first work, let's say problem in a motherboard. After you plug in the DC and the charging ammeter, your first job measure the VPH. In Qualcomm, we call VPH. In MDK, we call V system, right? Measure the VPH or V system line, right? In this line, you will get a 3.7 to 4.2 volt, right? Connect the power source, charger or battery, you will get this voltage. This is a main voltage, primary voltage, right? A primary voltage, right? If you did not get this voltage, right? Now, there are two situations. If you did not get this voltage, let's say no voltage, but line is okay, or second, a short circuit. So if this line is a short circuit, there are many methods I'm already described in many videos. You can watch the video and find the short circuit. Now, if there is a no short circuit, let's say, but still there is a no VPH. Now, VPH is a primary voltage. Without VPH, your phone does not turn on. So first job made the VPH. So in this line, you will check PMID, boot cap, right? Your VPH coil, right? And your charging IC, right? Check all these points and you will get 100% reason why VPH is not there, right? Because in this video, we talk about the buck section, right? So that's why we did not talk about the VPH, just a normal information. VPH is most important part, right? So if VPH is not there, first work on VPH, made the VPH, after go to the power IC. Clear? Now let's go to the buck section, right? In a deep level. So clear this, and now one more thing. This VPH line enter multiple times, like this is your PMU. It goes multiple ways, right? Minimum, like in this buck lines, 9 bucks. So VPH enter. So VPH enter 10 plus ways in this IC, right? 9 for the buck section, other for the power, enable, activate the other work, right? Now, for the entering, you will see there is a capacitor on for each and every line, a filter capacitor, right? Now let's go to the schematics. Now your first line called V system. In this line, you will get resistance. After this resistance, this line goes to the V system SMPS section, right? SMPS. Switch mode. Power supply, right? For enable the PMU, right? So if this resistance open, because this resistance in a series, if this resistance open, missing, damage. So if this line missing or damage, your PMU, right? does not work, right? So your phone in a dead condition, right? So check this resistance. If you see in schematics, this resistance, check this resistance. So you get your SMPS section is enabled, right? So your PMU is activate. Now next, delete this. After this, as I told you, there is a one input power for buck lines, right? Like 9 bucks for 9 inputs, right? So your VPROC input. So a V system line, right? Come here with this capacitor, pin number A6B6, right? Through this input, right? Your PMU, right? The input voltage is 3.7 watt. Let's say in a V system, right? After the PMU, step down this voltage and convert in a low voltage after switching with the buck inductors. This buck inductors, right? It's generate high ampere, right? After step down. So in this line, you will get a 0.6 to 1.2 voltage, but there is a default voltage, right? What is default voltage? I'll tell you. After this, there is a 0.8 volt. I mean, the default voltage is like when you measure, most of the time you will get a 0.8 volt on a stable mode, right? Now there is a two line. First we understand this. After we go to the default voltage, and I will show you another feature of the Borneo. Many people know. Let me show you those people who do not know. At VPROC 11 and VPROC 12. Now this line, let's say clear, VPROC 11 plus 12. Now these two coils, right, for the processor, your CPU mean SOC, right? Now VPROC means VPROC voltage for processor, right? Voltage for processor. Now when you look at the carefully, I will show you. There is a coil B and L, right? I will show you. Like when we go to the, like here, this is B and this is L, right? VPROC 12, VPROC 11, BL, right? Now what is BL? Let me tell you the B. The B means a big core, a big. L means a little. Now there is a two blocks like a big one, a big core, and the little, right? Both core had different power input, and both core has also a different output. I mean to say different working, right? Like a big core, you're responsible for your apps, right? As like a gaming, a big task, right? This voltage for big tasks. When the CPU needs more power, your SoC needs more power, processor needs more power. When the processor working on a big core, right, it needs more power. So this part working when, like in a touch, in a camera, like when these are working, right, it's need a low power state. So low co-working, right? I hope you will understood, right? So in this line, both of these lines are different. Similar, in a default voltage, you will get a 0.8 voltage on a stable, right? Now, let's see in schematics, copy this and next. Now, look at this. These two are feedback lines come from the CPU. If these feedback lines not come for the CPU to the power, this line open, your phone does not work, does not turn on. Your all bucks in a fluctuation, right? Now, this is called VPROC 1 section, right? So this all points, all pads connecting VPROC 11, same is as like a 12, right? So in front of you, there is a diagram, a PMU at multiple inputs, right? Through a PMU, a line called with an inductor called VPROC 11, after VPROC 12, a big and the little. And this line called a big, and this one is a little. Go to the CPU, same 0.8 volt, same 0.8 volt, right? Clear? Now we go to the back to the schematic again. Now after the VPROC, you will see a similar V code in, right? A voltage input from the V system. If this voltage input, right, not connected A15 or B15 pin, your V core output is not generated. Like if you get a voltage here, you must get the voltage here also. If your phone had a water logging, let's say, so these line internally, right, a burn or damage, right? So when you measure the voltage, you will get the voltage here 3.7. But on internally, these pins are not perfect, right? Not attached. It's not clear. So your PM, I mean to say your output is on a fluctuate mode, right? This is also a basic work. We forget always our basic things. Most of the time, we did not notice the basic things, right? We go to the directly to the CPU, also the other IC changing process, but we forget the basic work, right? If this line is open, let's say from here to here, whatever you do, change the PMU, right? A CPU revolve, whatever you do, this fault does not repair this motherboard because this small basic things are important. Always we run on a difficult one, but we forget about our small things. Now this is a V core. V core means voltage for core, right? A similar inductor, switching with the inductor. After this line goes to the CPU, like a V core section right here, right? So let me tell you about the V core. Let's say V core. Now core section is used for performing tasks like gaming, uploading, any tasks, right? Let's say you mostly heard the word a core, a single core processor when you buy a PC, laptop, any phone, a dual core processor, a dual core, a quad core, a octa core, right? Now, what was the difference, right? In a simple language, like core is like a person, a single person, right? When a single person do all your work, all your major tasks, right? Handle your apps, right? Gaming, touch inputs, right? On the other hand, if you get a dual core, like a same work by the two persons in a quad core, same work shared 4 person. So your task, whatever task, is much faster and smoother, right? So this voltage for the core section, which play important role, a crucial role in a performing tasks in smoothly, right? So in this voltage, you will get similar 0.8 default voltage in a stable, most probably 0.6 to 1.2 volt, right? Now a question comes, in this schematics, there is a no voltage written. How will I get to know? Let me show you one thing also. When you go to the Borneo, now look at this chart. In this one, this is called a block diagram. Look like block diagram. Your USB adapter or the battery to power source connected to the this IC called NT6370. Right? This IC work as a OVP. Also work as a backlight for the light section. right? You will see a BAT FAT connected to the battery. This IC produces the VPH, and this line V system goes to the box like this, right? Also, this line goes to the many sections. So this is a block diagram. How to read this block diagram, we will cover in another video, right? Now let me show you one thing more. Now there is a buck voltages. We see VPROC 0.5 to 1.2, 0.8, right? A default voltage, right? Also a 5000 milliamp. As I told you, this line is a high ampere line, right? It's generate a high ampere. So 5 amp on this line, right? A 0.8 voltage. This is a company data sheet, right? For processor 2, right now we see a V core, digital core, always on 5000 milliamp, 5 ampere, 0.8 voltage. Okay. So we go to the again, clear this and go to the schematics. I hope you understood, right? A V core, a core section, voltage for core section, right? The similar input for the core section. Let's withdraw this. After that, there is a core section called V core, right? In this line, similar, you will get a 0.8 voltage. Now we go to the schematics again. Now, after this, a V core, there is another voltage called V modem, right? Voltage for modem, right? This voltage also goes to the CPU, right? Similar like a two feedback lines, right here. If these two feedback lines not connected into the PMU, D15 or E14, right? Mainly the D15, your phone, I mean to say your PMU does not work. Clear? Now, in this line, similar, you will get a 0.8 voltage. Let me tell you about this line. First, clear this thing called V modem. Voltage for modem. Now, this line for modem section. Right? Now, what is modem section? In network plus communication section. Communication section inbuilt in your SoC. Right? We call a modem. Right? Through this, your CPU control the network and the communication. Right? I hope you will get it. If this voltage rail damage or open, you will struggle with the network section. But the phone is still on, except one condition: if there is a short circuit on this line. If there is a short circuit on this line, then your phone does not turn on. Then it's in a dead condition. Otherwise, it's in an on condition if you did not get on this voltage. Now, in another thing, in MTK phones, you will get this voltage without SIM, right? Without this, a voltage you will get without SIM. But in Qualcomm, you must insert the SIM. Means this voltage made after the phone turn on and insert the SIM. Right? Clear? So this voltage does not role play for the dead section. Now next is called VPA. Now this voltage also for the network section. How? Now in this line you will get a coil similar input after step down, right? So right, and this line goes to the, when you click it, just a second, when you click this line goes to the, let me explain you, a VPA, voltage for power amplifier. Right? Now, this voltage goes to the 4GPA, right? Now you will see there is a voltage called APT, right, in Qualcomm, right? A similar work, this VPA voltage. This is goes to the 4GPA for giving the boost voltage in any low situation. I will explain to you clearly about this line when we go to the network section. I will clear you all the doubts about this line. Now let me share with you how much in this line a voltage or data. I mean to say, now in this line you will get say a VPA last. Now a default voltage is a 0.5, but a 0.5 to 3.4, right? So in this you will get default voltage a 0.6 voltage, but normally 0.5 to 3.2 voltage, because this voltage is a variation voltage. When the network needs more power, this voltage increase and give it to the 4GPA, right? Now after this there is a call VSN1 and VS2, right? Let me tell you about. Now VS1 in Qualcomm phones you will heard about higher LDO, right? In this line you will get a 2.2 volt, basically a 2 volt default voltage. Now this line, just like a PMU, this is a PMU, right? It get back to the similar IC, right? This is called a VSN1. In this line you will get a 2 volt. After this voltage, PMU generate many LDOs, right? Like 1.8 volt, 1.6 volt, 1.4 volt, 1.2 volt, 1.0 volt. All the LDOs generate the help of this. Now a question comes, why this LDO? I mean to say this voltage comes out when the VPH is in, especially for this. Why not VPH? I mean to say the PMU not generate through VPH all these voltages, because there are multiple voltages. As I told you in starting, there are multiple voltages like 1.1, 2.0, 1.6, 1.4, 1.0, 1.2, 1.1. There are multiple voltages, multiple LDO. To stable or maintain the voltages, we need a high ampere. That's why the switching is must. After switching, this voltage came back to the PMU, right? Clear? Now after that, a VS2, a similar VS2 we call in a Qualcomm lower LDO, right? In this line you will get a 1.2 volt approximately, right? Same feature, this voltage also came out from the PMU, right? Came out and came back to the PMU. Through this voltage, CPU generate, let's say 1.0, 0.8, 0.6, these kind of the LDOs, right? Now after that, we call a VGPU, voltage for GPU, right? This line also goes to the CPU, right? Copy this line, right? This line goes to the GPU section in your CPU, right? Let me tell you about this line, a VGPU. Most of the time you will heard about a GPU, right? When you build the PC or in your laptop, a major component play for gaming or for high-end video editing for the graphics are called GPU, right? Graphic processor unit, a special processor for the graphics, high-end graphics, right? In your SoC, right, in a mobile phone, there is a part called a GPU for the graphics, right? In this line, you will get a similar 0.5 to 1.2 volt, default voltage is 0.8 volt for the graphics, right? As I tell you, you mostly heard about in a GPU when you build a PC or buy a laptop, you will mostly heard that for the better graphics, for the better gaming experience, you must need a good GPU, right? Similar in your SoC, there is a GPU section, right? Now this voltage is also play a crucial role, right? Now if this voltage damage or open your phone in that condition, clear? Now after that, there is just a second. Now this voltage is called VDRAM. In this line, you will get a similar default voltage as 0.8 volt. If this line damaged or open, your phone does not work, right? Now these all bugs are important role play. Now, I hope you like this video and this information will help you while repairing the phone, right? This bug information, how the bug section work, the bug inductors work with the CPU, with the power, right? This is a common information. I mean to say this is a normal one, right? If you want to go deeper, right? Like how to double PMU work, how to triple PMU work, how to 5 PMU work in a 5G phones, how to latest phones, a circuit working, how to read schematics. If you want to go more deeper, gain more knowledge about the diagrams, about the circuits, right? If you want to grow in this field, right? So join our classes. We give you a best information, best knowledge, right? Now, if you like this video, like this content, right? Give a thumbs up. I mean to say like on this video and share this video. Also give a lovely comment. Also, you can comment us whatever the next video, right? If you want, right? So love you all. We will meet you in the next video. And I hope you will always support me. Thank you so much. We will meet you in the next video.